All right, so let's go ahead and let's take a look at this problem set. So I'm recording my video right now with my children still awake, so you might hear them in the background, so we'll see how it goes. Okay, so I'm looking for the inverse function, and I'm looking for the derivative of the inverse function when on the inverse function that my x value is 5. That means on my original f of x function, this 5 here actually represents my y value. So let's just be clear. I'm going to first find my coordinate point on my original function, and then I'm going to use it to find my derivative. So if x is equal to 5 on my inverse, then 5 is my y of my f of x. So x cubed minus 3x squared plus 8x plus 5. And when I subtract 5 from both sides, I get 0 is equal to x cubed minus 3x squared plus 8x. So then I get x is x times x squared minus 3x plus 8. And so essentially I get x is equal to 0, and then I get this quadratic where when I look at these solutions, they're all like whole numbers. So essentially, I could use a quadratic formula. I could see if I get any imaginary numbers. But when I look at my solutions, they're all not like weird radicals. And this does not factor. So I'm going to just go with the fact that maybe what I'm looking at is the coordinate point on f of x, that I'm looking at the coordinate point of 0, 5. So then on g of x, that coordinate point is actually 5, 0. Okay, so again, I wanted to find the derivative of the inverse function. So x is equal to y cubed minus 3y squared plus 8y plus 5. And then I take the derivative. So 1 is equal to 3y squared dy dx minus 6y dy dx plus 8 dy dx. And now I can factor out a dy dx. So 1 is equal to dy dx times 3y squared minus 6y plus 8. And so I'm dividing both sides by dividing both sides by that term so I can get dy dx by itself. So I'm 1 over 3y squared minus 6y plus 8. So I'm looking at when y is equal to 0, so I plug 0 in for my y's, and I get 1/8. And that is letter B. Okay? All right, moving to question 3. So my f of x is equal to x to the 6th. My derivative is equal to 6x to the 5th. I want it at x equals 1. So f prime of 1 is 6 times 1 to the 5th, which is 6. All right, question 5 looks like L'Hopital's rule. So I'm going to take the derivative limit as x approaches 0, e to the x minus 1 over 2x. I have to do it again. Limit as x approaches 0, I get e to the x over 2. When I plug in 0, e to the 0 over 2 is 1/2. Okay, and that is almost it. Let's see. There's question 6. Is there not a 7? That's weird. That's because I can't count. Okay. 5, that would be 6. I guess this guy would be 7. So the limit as h approaches 0 represents the definition of the derivative. So f of x is equal to ln of x. The derivative of ln is 1 over x. I'm looking at it at 2. So f prime of 2 is equal to 1/2. Okay, is there another question? Okay, so that would have been question 7. This would have been question 8. And that's it for this one. This is 2-16. So let's go to the 2-16 problem set here. Okay, so question 1, my f of x is equal to x to the 2/3. So f prime of x is equal to 2/3 x to the -1/3. And I'm finding it at 1 here. So 2/3, 1 to the negative 1/3. It actually doesn't matter here, but technically this is 1 over 1, and it is the cube root of 1, which is just 2/3. Okay, so then question 3, f of x is equal to x to the 4th. The derivative is equal to 4x cubed, and I'm finding it at 2, so f prime of 2 is equal to 4 times 2 cubed, so that is 32. And then here, my f of x is equal to 2x squared minus x. So the derivative, ooh, my handwriting's terrible right now. F prime of x is equal to 4x minus 1. And I'm trying to figure out what happens at 3. So f prime of 3 is equal to 4 times 3 minus 1, which is 11. And then there's question 6, and that is it for this section.